Hello everyone, now we will do the question number 17. List 1 describes the thermodynamic process in 4 different systems. List 2 gives the magnitude either exactly or close approximation of possible changes in the internal energy of the system due to the process. I have taken the data separately. You can see there is a 10 power minus 3 kg of water at 100 degrees Celsius is converted into steam at same temperature at pressure of 10 to the power of 5 pascal. The volume of the system changes from the 10 to the power of minus 6 meter cube to 10 power minus 3 meter cube in the process. Latent heat of water is given 2250 kilojoule per kg. I have taken the data. Whenever water is converting into the steam at the same temperature, there is you can see that latent heat process can be observed here. Now you can write the energy due to the process is Q is equal to delta Q, right? Delta Q is equal to M into L. M value is 10 power minus 3, L value is 2250. If you write the value is 2.25 kilojoules energy is there, and in this case we can see there is a work done. So what is a work done value? P into delta V you can take. Delta V value is 10 to the power of 5 into 10 power minus 3 minus 10 to the power of minus 6. This value approximately 10, this value we can take approximately 10 to the power of 5 is there now. 5 into 10 power minus 2 is 10 power square joule. You can write that value is 0.1 kilojoule approximately I have written. You know that delta U is equal to delta Q minus delta W. This value can be written as 2.25 minus 0.1 approximately I have written. You can see at 0.1. The value is 2.15 kilojoule. So it is 2.15 kilojoule. Is there any option like this? Approximated value is 2. Why? Because they are asking close approximation. So first one is P. Only one option is there. This we can tick. Okay. C. Directly after looking that we can take the answer. Anyway, we will do the remaining things also. There is a 0.2 moles diatomic gas is isobarically expanding this from Vi to Vf is 3 V2 3V and temperature is 500 Kelvin. R value is given. So you need to calculate delta U. Delta U is equal to, you can write NCV into delta T only every time. So N value is 0.2. CV for the diatomic is 5. R divided by the 2 for diatomic gas, and delta T value. So what is the final temperature? You know that V by T is V1 Vi by Ti is equal to V final by T final. So if you do this, this one is increases by 3 times. Obviously temperature also increased by 3 times. So T final delta T value is T final minus T initial. You will get 1500 minus 500 is 1000 Kelvin. Substitute there 1000 Kelvin. So we can get the value is 0.1 into 5 into R value is given 8. So you can write it as 8 means approximately you can take the 4 kilojoules. Not approximately, exactly we are getting 4 kilojoules. Substitute there anywhere. Second one is 4 kilojoules. Okay. Third one. N is equal to 1, there is a ideal gas. N is equal to 1, monoatomic gas. Adiabatic compression is taking place. V and Vf is given, Pi is given, Pf you need to calculate. You know that in adiabatic process, Pi Vi gamma is equal to P final V final gamma. PV power gamma is constant. Substitute there. P initial is 2, V initial value is 1 by 3 whole power. Gamma for monoatomic is, you know that 5 divided by the 3. Substitute there 5 divided by the 3. P final V final value is 1 by 24 whole to the power of 5 by 3. If you substitute there, you can get the P final value is 2, 1 by 2. This is 1 by H. You can write it as 1 by 3 divided by the 1 by 4. So you can get 8 power 5 by 3. So 8 power 5 by 3 means 2 into 2 cube whole to the power of 5 by 3. 3 get cancelled. 32 64 kilopascal will get. Now we have delta U in this. Delta U value we can write it as N CV into delta T. what is NCV into delta T. NCV value, you know that R by, so I will write N is equal to N. So for monoatomic gas, it is 3 by 5 into R into delta T, you will write. The same relation you can write it as delta U is equal to 3 by 5 R into delta T is equal to P into delta V also you can write. Otherwise you can write it as P final minus P final V final minus P initial V initial also you can write. You substitute there 3 by 5, P final value is 64, V final value is 1 by 24 minus P initial value is 2, V initial value is they have given 1 by 3. If you substitute there, how many times we can get here? 8 times, it is 3 times. So you can get the 3 by 5, 8 minus 2 is 6. So 6 by 3 is 6 by 3. What is the 6 by 3 value here? You can write it as 8 minus 6 by 3 is 2. Okay, so just observe that value of this, I'm sorry, this is 3 by 2 only, not 3 by 5. CV value is 3 by 2 R, CP value is 5 by 2 R. So you can observe that this value is 3 by 2 R. This can cancel 3, whatever relation is there, you can write 3 kilojoules. 3 kilojoules. Now check that it is 3 kilojoules. T. Last one, 3 moles of diatomic ideal gas whose molecules can vibrate is given by 9 kilojoule of heat and undergoes isobaric expansion. You observe this, it is also vibrating. Now in the last case you can see N is equal to 3 diatomic. So in diatomic CV value is actually it should be 5. Now it will be 7 R by 2. Why? Because vibrational, one vibrational potential energy, one vibrational kinetic energy have to add extra. CP value is 9 by 2 into R. You know that delta Q in isobaric process, isobaric expansion is given NCP into delta T. Now you can write NCP value is 3 into CP value is 9 by 2 into R into delta T. That value is given 9 kilojoules. If write 9 and 9 get cancelled, finally you can get the value of this is 3 by 2 R delta T value is 1. Now you write delta U. Delta U is NCV into delta T. N is 3. CV value is 7 by 2 into R delta T. Now you know that 3 by 2 R delta T term is there, no? This can be written as 1. So you can write 7 kilojoule. So delta U value is 7 kilojoule. We can see value of this is Q. So anyway, we have identified that option C is the correct one.